Good morning, everyone. Thank you for coming here. I'm going to be talking about connectivity and IIoT options. And there's a difference between industrial Internet of Things and Internet of Things, and I'll be teaching you about that today. Who is MultiTech? Well, my name is Dave Smith, and I'm the Senior Vice President of Engineering and Innovation at MultiTech. MultiTech has a company that's been in business for about 45 years. We're based in Minnesota. We're a manufacturer of a wide array of connectivity options, including M2M services, cellular services, and IoT services, and products. We are a US-based engineering firm. We offer not only our standard products that you can buy and customize, but we also offer value-added services such as forward and reverse logistics, custom engineering, especially through our sister company, which is Connected Development. Well, they will do a full custom design for you that we can then turn around and manufacture for you. We are a top 100 M2M company, and we're working to be a top 100 IoT company as well. So let's talk about technology, because that's what I'm interested in. We have different kind of challenges when you're trying to connect IoT devices. And what's interesting is these challenges are pretty common across different use cases, across different industries and markets and things like that. And they're very difficult to balance, and every solution is a balance of these challenges. Some of them, or most of them, require battery operation for endpoints. You want them to be reliable, and you can go down this list. Harsh environments, long range, scalable, full duplex, all these different things. And how do you balance all these different requirements? Well, the answer is basically you can't with any given solution. From our experience in a wide variety of markets, most IoT solutions require more than one technology. And there are three general ones today in the wireless area that we use to pull to make our solutions in IoT markets. You have your LAN devices. That's Zigbee, Wi-Fi, Bluetooth. We're all familiar with that. They're nice. They have really high bandwidth, but they have short range, and they're not very good for battery life. So if you have tiny little devices that you want to go a long distance or get through a building or something like that, Wi-Fi isn't so good, or Bluetooth or Zigbee. But then we have the cellular side, and you can add satellite to that too, but that's far less common. Cellular is much more of a wide bandwidth and a longer range technology, and it's great. It's pretty much ubiquitous. It's around pretty much wherever you're going to go. But the problem with cellular is that it doesn't really do well with batteries. And you have this recurring monthly subscription cost generally associated with it. So most business models in the IoT world can't really handle subscription-based, or what we call operational expenses. And then you have low power WANs on the right side, where you're trading off this high bandwidth for much longer range and longer battery life. And those are really good for little end devices that want to send little bits of data frequently or infrequently, but hopefully more infrequently than frequently. So these are the three categories of wireless connectivity options that you use to pull from when you make IoT solutions. So here's where we want to talk about IoT versus industrial IoT. Okay, completely different markets. They have completely different focus. In the IoT world, it's generally about a high volume, low cost product. Think of a Fitbit, okay? The interesting thing about a Fitbit is they are all the same, right? You don't buy a Fitbit and put your own software on it, right? It's a one size fits all. They're identical. And the thing about IoT devices generally is they often have frequent interaction with people. Again, think of your Fitbit. You wear it on your arm. And that means, though, that it's probably not going to be in a very harsh environment, because people don't generally go into harsh environments, right? In addition to that, you're all familiar with commercial products. They have very short product life cycles. Apple replaces their products once a year, right, if you're lucky. If you try and go a cellular dongle from Verizon, try and buy one of those can change as frequently as every 3 months. So if you're trying to supply a product that you can deliver over a period of years, it's very difficult to do. And in addition, this is another key characteristic of IoT devices, is they share their data broadly. Again, imagine your Fitbit. Your Fitbit's going to connect to your phone. It's going to have maybe a Fitbit app. There's a health app on your phone. You're going to forward that data out into the cloud, and perhaps share it with the Fitbit cloud, but you might also share it with your personal trainer, and you can all see that I have one, or your doctor, right? If you're trying to monitor your heart rate, things like that. So this data is often shared broadly with IoT devices. Now contrast that with industrial IoT. The number one thing I'm sure you've all heard in the industrial side is security, right? High reliability. And part of security is controlling where the data goes, right? Not letting anybody get to it. And another big thing with industrial IoT is managing end devices, because they're often put in harsh environments where people don't go. They don't have a lot of interaction with people. Imagine a little control on top of a streetlight. People aren't often going to be climbing up there to touch this thing, do anything with it. So you need to have a remote way to manage it and maintain it and all that. And it has to be able to be deployed and sit there for years, outdoors. In addition to that, you have to have a long product life cycle. Let's take the streetlight example again. There's a lot of streetlights in the country, right? If we start today and we want to wire up every streetlight in the country, it's going to take a few years. And during that time, they're going to put out more streetlights because there's development going on. And then once you get that done, you haven't made any money or saved any money or done anything really, right? So you need to have an operational life on this thing that's going to have to be for years to make up your investment. So that whole life cycle could be a decade, maybe 2 decades. And all during that time, you're going to have lightning strikes, you're going to have cars knocking down light posts and things like that. You're going to have to replace these things, and they have to be identical. So you can have a consistent business model, a consistent cost model. So you have to have a very long product life cycle. In addition to this, you also have data that is not widely shared. It is often sent to only 1 or maybe 2 different places, and is relatively jealously guarded for one reason or another. Pick streetlights again. You don't want a hacker to be able to shut the streetlights off at the wrong time, and people maybe get in car accidents, or pedestrians get hit because they're not seen. So you want to tightly control where the data goes and how it's used. So that's industrial IoT versus regular IoT. So let's talk about LPWAN technologies. First of all, you've heard the term LPWAN, right? It's a generic term, it's an umbrella term, and it really refers to 4 characteristics. It doesn't refer to a particular technology, it refers to 4 characteristics of that technology. One is long range. The second is long battery life. And then there's low cost, right? And low bit rate. So you can cut it in long, long, low, low, right? These are the 4 characteristics of an LPWAN. Now contrast that with cellular. Well, cellular might not hit the low cost, they're not going to hit the low battery life. But they probably hit the wide area, relatively speaking. And the data rate, well, they have much higher data rate. So this is unique to LPWAN. So when people use that phrase or that word, this is what they're referring to. So how do this LPWAN and specifically LTE or cellular technologies, how do they interact, right? Because these are overlapping markets. And what you found is broadband cellular for a number of years now has enjoyed kind of a monopoly because they were really the only ubiquitous network that you could connect to easily and send data through. I mean, LPWAN is fairly new. And so it dominated most of these vertical markets here for a while. In 2016, there's been a large acceleration of LPWAN applications. And what you can see, if you look at the trend there in 2019, it just means that in those particular verticals, it's really hard for an LPWAN to address a market. I mean, when you're talking about, smartphones, tablets, and gateways, people are going to want to watch video, for example. And LPWANs have a low bit rate, so they're not going to support that. So there's 3 different kinds of LPWAN networks, okay? We talk about all 3 of these, and MultiTech was one of the first to identify the enterprise one, so I'll explain that one. in a minute. But the first one that most people think of is public. And that's where you have a carrier, and you can pick them like AT&T, Verizon. But actually in Europe, there are a bunch of smaller companies that are taking the role of carriers like Actility, Orbitwise, KPN, Swisscom. They're a real carrier though. And what do? They provide a network. And you would buy an endpoint and connect it to their network. So what's good about that is you have a low capital expenditure up front because all you're buying are endpoints. You don't have to create a network, you don't have to set anything up. But you trade that off for higher operational expense in the future because every month you're going to pay for each device to use their network. And for many people, network management, or being able to control the network and decide where a network is, right? Because you may want to put an endpoint in a spot, but the carrier doesn't have coverage there, you're out of luck. But you can usually do mobility, although NB-IoT, I'll talk about that later, is not really good for mobility at all. It doesn't really work. But generally, you can move things around, and you can get things out very quickly. So that's what's really good about the public network. Let's flip over to the private side, the opposite end. Private networks are, let's say you have a business, and you want to, monitor your freezer and your fresh food area, or something if it's a grocery store, or you want to monitor something else, and it's really geographically constrained, maybe one building, maybe a small area, and you want that data for your own uses. So you set up a private network. That way, you don't have to pay the operational expense every month. Saves you that. You do have a little bit more capital expense up front to buy a gateway or a router and set up your own network. But you do enjoy the ability to control your own network as well. And the key thing with that is your data never leaves your hands. So if you don't want others to see your data, you set up a private network. So the middle one is the one that we're seeing a lot of growth in. Probably, well, the vast majority of the customer contacts we come into right now are enterprise level networks. So what is an enterprise level network? It's a large private network, essentially. Imagine a large company that might be geographically distributed or have multiple locations. They want to get data from these locations and aggregate them up into their own systems for their own uses, right? Imagine McDonald's, and you want to have little networks at each McDonald's spot that tells you all sorts of stuff and aggregates it up to the corporate headquarters. And you don't want that data leaving your hands because it could be misused, right? It could be used against you in some companies. So you use an enterprise network. Well, the great thing about that is you have low operational expense because you own the network. And your network management is awesome because you put the network wherever you want it to be. So you already know that wherever you have stuff, it's going to be covered and you can get that data. It's not so good for your operational or your capital expense because you're going to have to create the whole network yourself and you're going to have to manage and maintain it, right? So you've got a little bit more capital expense up front. But you also completely own the data. It never leaves your network. So think about what we talked about, IoT and industrial IoT. Industrial IoT is more of the enterprise private side. IoT is more about the public side. Now, what we find is we have the public operators today. They recognize this, believe me, especially in Europe. And they're fighting a battle now between enterprise and public. And their approach is, we give you the security that you want and need, and we can't touch your data, and that's what they try to talk about. But at the end of the day, for a company that really wants to own and maintain, they don't want to take that chance. They want to own the whole thing. It's that important to them. So they want an enterprise network. So this is what you're going to see out in the market today. So this is actually a really cool slide, and I can say this because I didn't make it. Daniel Kwan made this, okay? We've updated it several times, but it's really good, and you should get a copy of this and keep it with you, because people often ask details that you can get off the slide, and by answering that question, you can get to the real questions, but they often think that all the most important stuff is on the slide. What we have here is we have on the left 3 columns are 3 LPWANs, and on the right 3 columns are the corresponding LTE or cellular technologies. Now, I know it's kind of hard to see. That's okay. That's why I said we'll get you copies. But what I can show you is they all have similar, the top parts are all very similar in terms of data rates and battery life and things like that. Okay? They're all, within a few points, dB or volts or whatever, of being the same. They all work very much the same. But the interesting thing is LoRa, the reason why it's in green, all the rest of those are public networks. Public network only. So if you want to do a private or an enterprise network, Sigfox, you can't do that. And with LTE, you can't do that. Ingenue will try and tell you you can, but they have to do it all for you. So, and then they manage and maintain it. So how is that different than a public network? I'm not sure. But here's some other things too. LoRa is the only one that allows you to do mobility. LTE Cat1 and Cat-M, yes, but they aren't really LPWAN. We included them there to be nice and to give you some additional information, but it's really NB-IoT that is the LPWAN competitor. And NB-IoT, you can't move around. When your device connects to a tower, it's like, imagine a dog with a chain to his doghouse, right? You can walk all around that doghouse, and as long as that device is still within talking range of that tower, yes, it can move around. But as soon as you go out of range of that tower, the device has to stop, and it has to look around and try and find another tower and then go through a join process and then start talking again. So it is not like when you're driving down the highway with your cell phone and you're having a conversation, and what you don't know is you're being passed from tower to tower to tower. You can't even tell on your phone call. It's not like that with NB-IoT. In addition to that, Ingenue is especially sensitive to being moved around. The way their technology works is it has to have a really tight phase lock on a signal. And so if I'm moving this fast, it's going to lose lock. So you can't even put it on a dog and track the dog. It'll lose lock. And this is even when it's within range of the same gateway. So these devices really can't move. In addition to that is location. The other key thing that the other ones don't do. You're going to have your traditional, I'm talking to this tower in cellular, right? And get that big blue circle on your map of where you could be. But all the rest of them, they don't support location-based services at all. Unless you go to a third-party provider and you mix it with Wi-Fi, right? If you're all familiar with LBS, you might not be. So a lot of times you can use local Wi-Fi networks, and you use a cloud-based service that will kind of sort of tell you where you are. It's called location-based services. You would have to use those and get a kind of sort of where you are answer. Whereas with LoRa, right now, directly off of the LoRa signal, and not using GPS or anything like that, the idea of locating an endpoint is definitely been done, and they're improving the accuracy. Today, the accuracy is about 100 to 200 meters, which is good enough to say I'm in the lake or I'm on dry land kind of thing. And for many applications, believe it or not, that's totally cool. For example, consider agriculture, and you just want something one on each acre. Okay, that's good enough. So the accuracy is being improved right now, and the goal is to get down to about 10 meters. I'm not sure that's going to happen anytime soon, but a few tens of meters I think will happen yet in 2017. But that's the only technology that will support that.